Hello and Assalamualaikum. My name is Muhammad Iqbal Saini. I would like to give an overview of the principle of chemical engineering and describe about unit operation. So firstly, principle of chemical engineering is a set of guidelines for planning, evaluation and improvement processes involving transformation of raw materials to useful product form. The basic of principle of chemical engineering such as mass and energy conservation, specifically mass balance and energy balance.
So in this integrated design project, it is important for us to apply the fluid mechanic knowledge in order for us to analyze the fluid behavior when it was at rest and it was in motion. So in order to analyze it, we need to go through the calculation part. And in the calculation, we need to consider the pipe size, the pipe material, the viscosity, the temperature, the flow regime, the Reynolds number, the pump fittings and valves, and many more. So in the calculation part, that is where you will know, that is where we can analyze the fluid behavior.
Unit operation is a basic step in a process which involves physical change or chemical transformation in the system. There are few highlighted process units in this process plan. First unit is sulfur combustion unit, where sulfur is burned with oxygen supply to form sulfur dioxide gas. Next, absorption of sulfur trioxide. In this unit operation, sulfur trioxide is absorbed into concentrated sulfuric solution to form oleum. Then, the dilution of oleum, where oleum being diluted with water to produce desired concentration of sulfuric acid. Lastly, storage and distribution. In this unit operation, concentrated sulfuric acid is stored in a storage tank for further distribution.
Hi, my name is Irfan. Now I'm going to continue with mass balance for reactive system. From the lab session regarding the combustion of sulfur, we get that the molar flow rate of sulfur is 25.1 mole per hour and the molar flow rate of the air is 254.8 mole per hour. We assume that the conversion of rate 100% and use the data from the lab session as our assumption also. After we carry out the mass balance, we get the molar flow rate of the sulfur, oxygen, nitrogen and sulfur dioxide produced. We use the molar flow rate to calculate the mole fraction of the component from inlet and outlet. In order to carry out the energy balance, we need to calculate the specific enthalpy for each component. We assume that the reference temperature is 25 degrees Celsius, no moving objects, no vertical distance between inlet and outlet, therefore the kinetic energy, potential energy and work shaft is 0. When there is no work shaft, kinetic energy and potential energy, we get Q equals to change of enthalpy. After carry out the energy balance, we get Q equals to 2735.73 kJ per hour. On the basis of 25.11 mole per hour sulfur, 2735.73 kJ per hour of heat was released from the combustion chamber.
Assalamualaikum and hi, my name is Fadi Alami bin Khairil. So I will explaining about how to calculate the mass balance and energy balance for non-reactive system as well as the mole fraction and mass fraction. First, to calculate the mass balance and energy balance, we need to determine the DOF. For the DOF, we need to list the independent equation and unknown. Then, if the DOF is equals to 0, means that the equation is solvable. To calculate the mass balance, we need to find the N1 first by using overall equation, and then we need to calculate the specific balance for each molecule. We have to times the weightage with the mass flow rate to get the specific balance for each molecule. For the mole fraction, it can be calculated by dividing the number of mole of one component by the total number of all the components in the stream. For the mass fraction, it is the ratio of mass of the component to the total mass of all components in the stream. For the energy balance, the assumption is there is no change in potential energy, work and kinetic energy, and N9 plus N10 is volume. Since there is no change in potential energy, work and kinetic energy, we have to calculate the change in enthalpy only for the energy balance. Next, to calculate the energy balance, we need to form a table which has the detail about the flow rate and the specific enthalpy of each element for inlet and outlet. For the flow rate, we already calculated it, and for the specific enthalpy, we need to calculate it by using heat capacity equation from table B2. If there is change in pressure, we have to calculate by using formula that is molecular weight divided by the density of the molecule, and each time with the change in pressure. After already get all the information, we can calculate the energy balance. We have to calculate the total enthalpy for outlet and inlet by times the specific enthalpy with their respective flow rate. When we already get the total inlet and outlet enthalpy, we have to find the difference for both of it by substituting the outlet enthalpy with the inlet enthalpy.
Okay, so for the calculation part in fluid mechanics, we state all the assumption. After we state, we calculate the volumetric flow rate by taking the mass flow rate over the density. We got 1.5847 times 10 power negative 4 meter cube per second. And then we calculate the velocity by using the volumetric formula. We got 0.0222 meter per second. In order for us to know the flow regime of a sulfuric acid, we calculate for the Reynolds number. We got 198.86, which is less than 2000. So our flow rate is actually alumina. And then we continue with calculating the friction loss. Friction factor 16 over Reynolds, and then we got 0.0804. So after calculating the friction loss, after calculating the friction factor, we calculate for the friction loss, and then we got the value 0.2377 joule per kg. And then we calculate for the pressure drop using this formula, this long formula, and then this long equation, and then we simplify it. We got this formula, substitute all the value, and then we got the value 92.32 Pascal as our pressure drop. And then we calculate for the work pump using this long equation also, but we consider for the work pump, elevation, and friction factor. We calculate it, substitute all the values, and then we got the value. Work pump is 294.49 joule per kg.
Hi, my name is Danisha, and I will present about the product delivering strategy. So when constructing piping system, the principle of conservation of mass is important to guarantee the same quantity of product will enter and depart the system. We use Bernoulli equation that describe the relationship between pressure, velocity, and elevation, and the pressure drop in a pipe system can be determined using this equation, which is crucial for choosing the right pump size. Since the pump is necessary to transfer the product to the storage tank, friction factor is one of the most important factors in determining the pressure drop and pump power. Next, for the pump selection, the pump is chosen based on the flow rates of the product, its viscosity, and the required pressure difference between the source and the storage tank. For this case, we use centrifugal pumps, which are suitable for handling a wide range of fluid with moderate flow rates and pressure. The pump head must overcome the piping system pressure drop as well as the elevation difference between the final unit operation and the storage tank. In piping system, we use stainless steel since its corrosion-resistant material, which is suitable for making sulfuric acid pipe. The chromium in stainless steel react with oxygen to form a protective layer of chromium oxide on the surface of the metal, and the layer acts as a barrier, making stainless steel highly resistant to rust, acid, and alkalis. And while enclosing tanks and pipes that contain hazardous material, it will help to contain any leaks or spill. This also protect the content from contamination by airborne pollutant, moisture, or other contaminants. The storage tank design it is important in the production of sulfuric acid. When designing a storage tank, we should consider the capacity, the material, and also the shape of the tank. And for this, we use polyethylene for the material as it compatible with the sulfuric acid and is non-corrosive. And the capacity of the tank must be sufficient to hold the required product, which is the sulfuric acid. Next, the shape of the tank should minimize surface area in order to reduce the evaporation losses and provide the structural stability. Next, for the pump power, we can use this equation to estimate the value of pump power when the tank is located at 3 meters from the ground. And the efficiency should be around 70% and above in making the system work efficiently.